Hello, this is a project of Team 9. The members are as shown. Our project is of a wooden coat rack. The inspiration has been taken from an oak tree. The branches of oak trees are big and heavily strong. Therefore, it allows the trees to withstand any strong hurricanes or windstorms. A typical coat rack contains a few small branches. Our model will have multiple long and short branches, like the branches of an oak tree, to keep a lot of clothes. Now we'll be going into the life cycle analysis of a wooden coat rack. We'll start off with materials needed, then we'll move on to processing, and then to transportation. The materials needed is oak wood, biodegradable plastic, and rubber.
Oak wood is used for basic frame construction and stability. The impact of this oak wood is by cutting of trees can result in loss of habitat for different species and loss of oxygen in the atmosphere. Biodegradable plastic is the plastics that will be used inside of the holes of the wood for the branches of the rack to allow rotation in any direction. The impact of this plastic is that there are estimated to be 270,000 tons of plastic floating in the world's seas. For rubber will be used to provide friction at the bottom of the coat rack and at on the mouth of each branch for the clothes to get a hole. As rubber decomposes, the chemicals in the rubber leach into the soil and nearby water sources. Processing. An axe is used to cut the wood, which rests on the ground in the forest, into desirable shapes. Tapers are used to take the latex sap from rubber trees. Joiners are used to smooth the surface of the rough wood to make flat edges. Injection molding is done by inserting into a machine that has chemicals such as PET, which are added to the biodegradable material. Attaching the rubber portion on the wood surface is done using strong glue. Drilling machine is used to create holes in the wood for the branches of rack to fit in. Trucks and trailers collect and deliver the raw materials to manufacturing factories and mills. Trucks and trailers distribute the processed products to different supply chains. Biological cycle goes from production, product, use, biodegradation, biological nutrients, and plants.
At this point, we'll be taking you through the cradle-to-cradle design, whether our model actually fits it or not. Now, there are actually 5 certification criteria. The first one starts with the material health. The second is the material reutilization. The third one is the energy used for production. And then we go on to water use and disposal. And the last one is social responsibility. Starting off with the material health, since we're using oak wood and biodegradable plastic and rubber, the oak wood and the rubber doesn't have a serious material health issue here since we're using it from the dead wood, and the rubber doesn't actually cause the trees to die. The only health risk attached to our product is the processing of it. However, we've got a solution for that, and that is we'll be using more biodegradable plastic, and recycling the plastic after its use would lower down the hazard. Now, the material utilization is the best part for our project. After the end of the wooden coat rack's life, it can still be reshaped and reused into different appliances. For example, it can be used as a pen holder, pencils, wooden ruler, and frames. What this would do is it will reduce the cost and preserve natural resources in the long run. Additionally, there's another advantage for us, and that is biodegradable plastics could be sent to bio-waste treatment, which can be decomposed by microorganisms in the environment. And lastly, rubber can be recycled and refurbished, and it can actually save a lot of money in the long run. Now, with the water use and disposal, this is slightly alarming fact for us. It takes around 22 gallons of water to make 1 pound of plastic. In fact, it takes at least twice as much water to produce a plastic water bottle as the amount of water contained in the bottle. Now, for the social responsibility part, the laborers collect the wood for a reasonable wage, and then they harvest the rubber in a bulk quantity. And they actually enjoy some good profits from it by selling it to the manufacturers and to the other industries and factories.
So our energy used for production, we use hydroelectric power. It's a source of renewable energy which uses the natural flow of moving water to generate electricity. A set of machineries must be used to melt the plastic and the rubber. This mechanism can be used for the machineries required to produce plastic and rubber. Hence, the non-renewable electrical energy that will be saved. Thank you, and hope you like our presentation. Bye.